Okay, here we go. I'm John Allison, Direct Master Record Arkansas Ames. I'm about to make a cold attempt at number one FRQ from 2025 AP Calculus exam. So we're going to open this. I have not looked at the problems, and I'm going to open them cold. I like to do this cold just so that I can kind of get a feel for how the students felt when they were doing this. So I'm also not going to post the problem on here because that's supposedly a violation of College Board copyright. So we're going to try not to do that. And here we go. So I'm looking at number one. I will put in the description of the video here a link to the College Board released FRQs. That way you can look it up here. So I'm going to look here and say, an invasive species of plant appears in a fruit grove at time t equals 0 and begins to spread. Function c defined by c of t equals 7.6 arctan 0.2t. Models the number of acres in the fruit grove affected by the species t weeks after the species appears. It can be shown that c prime of t is 38 over 25 plus t squared. Find the average number of acres affected by the invasive species from time t equals 0 to time t equals 4 weeks. So the average number of acres has an average value, and that means, let's do 1a, the average value can be given by the integral from 0 to 4 of c prime of t dt, and then divided by the length of the interval. So we can do this. I'm going to have to open up a calculator on the computer here because I don't have one with me. But I will enter that in the calculator. And then we will see also that that is going to be 1 over 4 times c of 4 minus c of 0 by the fundamental theorem. So that should give us a pretty easy n. We can calculate that real quick. Let me go to online calculator here. It'll take a second to get this up. I could have had it up before, but I didn't. Again, I've not looked at these problems. So now I'm going to make sure my calculator is in radian mode. It is. And I'm going to calculate. Let's just go ahead and do y equals. I'm going to go ahead and put 7.6 arctan in the calculator. Of course, that's second tangent. 0.2 times x in the calculator. And I'm going to get out of this. That's in my y1. And then I'm going to go to second bars. Oh, not second bars, just bars. I'm going to do y bars. And I'm going to do y1 of 4 minus y1 of 0 all divided by 4. So I'm going to do y1 of 4 minus y1 of 0. I'm going to hit enter, and then I'm going to divide it by 4. And I'm going to get 1.282. And that's acres. That's the average value for the first 4 weeks. Yes. Okay, so we're going to find the time t when the instantaneous rate of change of c equals the average rate of change. So that's not the average. We did the average number of acres there. Now we're going to do the average rate of change of c over the interval, which is the average rate of change Oh, you know what I did? I did this so wrong. This is why I do this cold. I just did the average rate of change. Part A, the average value of this. I about messed up. So this is 1 over 4 minus 0, the integral from 0 to 4 of c of t dt. I need to do this with the calculator differently. I almost messed that up big time. Should have known that. This is why I do it cold, though, so I can get the experience of the kids and realize we made a mistake. Let's try again. So that means now I'm going to go in the calculator. I'm going to do second math. Or no, just, sorry, math. And I'm going to scroll down where it says function integrate. Oh, I quit. Let's do 0.25. That's 1/4 times. Let's do the integral. From 0 to 4. Yes, I almost messed that up big time, didn't I? What I had found there was the average value of the rate of change, which is not at all what I wanted. That would have been really bad. So I have that function in y1, so I'm going to do the average value of y1 with respect to x. And for that, I get 2.778 acres. That's the average value. And on the exam, of course, just cross it out instead of erase. Now, let's go back and look at that part B. Now I want to find find the time t when the instantaneous rate of change equals the average rate of change. So we did find the average rate of change up here. The average rate of change is C4. The average rate of change is going to be C of 4 minus C of 0 over 4 minus 0. And that's going to equal, let's go to the calculator again. And this time I'm going to go to the table and get C of 4 and C of 0. 5.128. I'm not going to use those rounded numbers though. Minus 0 over, and this is going to be 4. I'm going to go ahead and do C of 4 in the calculator divided by 4. And so it's going to give me y bars, put y4, oh, somehow I did y1 there. That's not good. In the calculator. Y bars, y1 of 4. Then divide by 4. And that's my 1.282. That is what I found a minute ago. That makes sense. So the average rate of change is acres per week. 1.282 acres per week. I need to find t. Let's look at that problem again. I need to find the time t when the instantaneous rate of change. So when does c prime equal the average rate of change? So now I'm going to put in my Y2, I'm going to put C prime, which is 38 divided by, open parentheses, 25 plus T squared, or X squared in the calculator. Then I want to set this for only the derivative of graph. I'm going to graph it. Oh, I'm going to go ahead and do the 1.282 acres per week also. I'm going to go that in Y3. I'm going to graph that. And I'm going to set my window where I can see that better. I'm going to go from 0 to 4 for X. And we're going to go from 0 to 5 for Y. And I'm going to hit graph again. And I'm going to find the intersection using the calculator. So I'm going to do second trace, intersect. And that tells me that this C prime of T equals the average rate of change when T equals 2.154. So 2.154 weeks. Make sure that y'all can see that still. And you can. I'm going to do C. Well, that major mistake on A cost me some time here. But that's okay. That's why we do this. Show that nobody's perfect. And all right, let's go to part C. Assume that the invasive species continues to spread according to the given model for all times t greater than 0. Write a limit expression that describes the end behavior of the rate of change in the number of acres affected by the species. Of the rate of change. So C prime of T is the rate of change. And we can do this as a limit, and we can say that as T approaches 0, sorry, where T approaches infinity, and C prime of T equals 0. A limit expression describes the end behavior of the rate of change in the number of acres affected by the species. So, as the number of weeks gets larger, increasingly large, increases without bounds, let's say. The rate of change in the number of acres approaches 0. That's not too bad. D, at time t equals 4 weeks after the invasive species appears in the fruit grove, measures are taken to counter the spread of the species. Make sure you don't see that. You can't. oops, a function defined by a, or a of t, equals c of t minus the integral from 4 to t, 0.1 times ln x dx. Small the number of acres affected by a species over the time interval from 4 less than or equal t less than or equal 36. At what time t for 4 between 4 and 36 does a attain its maximum value? Justify your answer. So a prime of t is c prime of t minus 0.1 ln t by the fundamental theorem. We want to know when there's a maximum, so we're going to graph c prime of t minus 0.1 of t, or comes ln t, and find out when that is 0. So we're going to go back here, our calculator. I already have c prime of t in my y equals. So instead of the 1.282 again, I'm going to go to negative, or to 0.1 ln x. And I am going to make my y1 this time instead of what it is up there. Well, there we go. I'm going to make that y2 minus y3. All right, so now I've got my y1 set in the calculator to graph c prime of t minus 0.1 ln t. I need to change my window now from 4 to 36. Graph again. Oops, I got to change my y value too. That goes from 0 to 5, let's go negative 5 to 5. Okay, and so a prime of t changes from positive to negative. I'm going to go ahead and write up here a prime of t where it equals 0 once I figure that out in a minute. At t equals, changes from positive to negative on the graph. I'm going to go ahead and find the 0, second trace. 0. Left bound, right bound, all that good stuff in the calculator. At 11, that equals 11.441 or 2. I'm going to go ahead and put 2 in round week. Therefore, A of t is its maximum when t equals 11.442 weeks. And that should be sufficient. Let me go back and make sure I've answered all the questions. I believe so. So that should be it. Part 1. Messed up early on, fixed it. It should be a pretty good solution, I think. We'll see when the root comes out.